Math 1314, Tyler Junior College, Section 5.1, 2x2 systems of linear equations. Applications, mixtures. I love these types of problems. By contrast, most students despise them. I love them because with the correct perspective, they are fairly intuitive to get set up. And once you set it up, then you just hand it off to your procedures for solving a 2x2 system of linear equations. Mixture problems are fairly common in chemistry, pharmacy, or any other science where you're mixing solutions. So if your destiny is to go in one of those two directions, I would really pay attention to what's about to happen. A chemist working on a flu vaccine needs to mix a 10% sodium iodine solution with a 60% sodium iodine solution to make 50 milliliters of a 30% sodium iodine solution. Let's wrap our minds around what that stuff means. A 10% sodium iodine solution is exactly what it sounds like. It's a solution, 10% of which is sodium iodine, represented in blue. What's the other 90%? I don't know, probably water, but I'm not a chemist. A 60% sodium iodine solution would be the same thing. 60% of it is sodium and iodine. The other 40% is whatever, water maybe. We want to take some of the 10% and some of the 60% to achieve two goals. Number one, we need a total of 50 milliliters of solution. And number two, we need 30% of that to be sodium iodine. The question is, how much do we take of each? How many milliliters of the 10% sodium iodine solution should be mixed with how many milliliters of the 60% sodium iodine solution? So where do we begin? Well, the same way we begin with most word problems, we identify what it is we're looking for. Since we're looking for the number of milliliters of each solution, we need two variables. We'll call them, out of lack of creativity, X and Y. We'll say X is the number of milliliters of the 10% solution, and Y is the milliliters of the 60% solution. So we take X milliliters of this, Y milliliters of that, dump them all together, and we get this picture. There are two constraints that we're working under. Number one is the total amount of solution that we are trying to make, which is 50 milliliters. So for the total solution, we know that the milliliters we take in total from here, plus the milliliters that we take in total from here, have to equal 50. So that's a pretty easy equation. X plus Y is equal to 50. Milliliters from the first plus milliliters from the second equals 50 milliliters total. But we also need to focus on the sodium iodine concentration, if you will, or content. Let's start with how much sodium iodine we want when we're done. This is a 50 milliliter solution, 30% of which is sodium iodine. So if we wanted to calculate how much sodium iodine was in the final product, it would just be 30% of 50. We could calculate 30% of 50 by turning the percent to a decimal, 0.30, and multiplying it by 50. That's the sodium iodine content that we want. What's the sodium iodine content from each of the solutions that we're taking? Well, we can take the same approach by multiplying the concentration times the number of milliliters. The concentration on the first one is 10%, but how many milliliters of the 10% solution are we taking? X milliliters. So just like we multiplied 30% times 50 milliliters to get the concentration of the new solution, we can multiply 10% times X milliliters to get the concentration of the first solution from which we're mixing. So in other words, 0.10X represents the sodium iodine content that I will get from the first solution. How can I represent the sodium sodium iodine content from the second solution that I'm mixing. Same thing, 30% times 50, 10% times X, 60% times Y. 0.60Y. And we have our two equations. We need 50 total milliliters of solution, and we need 30% of 50 milliliters of sodium iodine. Let's go ahead and multiply these and call it 1.5, which it is. First equation is x plus y equals 50. Second one, if I eliminate the unnecessary zeros, 0.1x plus 0.6y equals, and 0.30 times 50 is 1.5. And now we have a system of equations, and it's no longer a word problem. Now we just have to choose a plan of attack. Our plans are substitution or addition, excuse me. If we're going to do substitution, we need to solve for one variable. If we're going to do addition, we need to set up a multiplication to create opposites. Either one will get the job done. Just pick a plan of attack and go with it. I think I'm going to choose addition. If I were to use elimination, I would either solve for the first x or for the first y. But I like the addition approach because all I have to decide is which letter do I want to get rid of first. Let's say I want to get rid of the x. I need to make these coefficients match. Actually, I need them to be opposites. If your coefficient is 1, it's easy to turn it into anything you want. I want the coefficient of the x to cancel 0.1x, so I need the coefficient of this x to be negative 0.1. Negative 0.1 is what I'm going to multiply the first equation by. That will give me negative 0.1x minus 0.1y equals negative 0.1 times 50 is negative 5. Get a calculator if you need the assist. Something is amiss here. 30% of 50 is not 1.5. 30% of 50 is 15. I'll tell you how I caught that in just a second. So our first equation becomes this. Our second equation is still the same. 0.1x plus 0.6y is equal to 15. And now we've set up the x's to cancel. When we combine the y's, negative 0.1y plus 0.6y is 0.5y. And when we combine the constants, negative 5 and 15 is 10. The reason I caught that is because if this were still 1.5, this would be 1.5, this would be negative, the y would be negative, and that doesn't make sense contextually. Yes, I processed that much up there. You do enough of these, you start thinking in advance like that. It's like playing chess. You should think multiple moves ahead if you can. Divide both sides by 0.5, and again, feel free to use a calculator assist, but you will get 20. So we know how many milligrams of the 60% solution we need, because that's what y represented. To find the other amount of the 10% solution, we just need to finish solving the system. Let's take the 20 and substitute it back into an original equation. I choose the first one. We know x plus y is equal to 50. Since y is equal to 20, we get x plus 20 is equal to 50. Therefore, x is equal to 30. And we're now ready to answer the question. We need 30 milliliters of the 10% solution, because the x represented that. And we need 20 milliliters of the 60% solution. We could even check this. That is a total of 50 milliliters. 10% of 30 is 3. 60% of 20 is 12. 3 plus 12 is 15, which is 30% of 50. So it all checks out. Just remember, if you're doing a mixture problem, there's almost always two equations to set up. One to represent the total amount of solutions that you mix together to get the total amount of the mixture, 50 milliliters. The other one usually representing the amount of a certain chemical. In this case, the 10% of it is sodium iodine in the first solution, 60% of it is sodium iodine. In the second solution, we want the final result to be 30% sodium iodine. So total plus total equals total, percent plus percent equals percent. Once you get accustomed to it, it's actually pretty straightforward.